Hello there, and welcome to this gentle journey through the cosmos. I'm so glad you found your way here tonight. Maybe you've had one of those days where your mind won't quiet down, or perhaps you're someone who finds peace in the vast mysteries that drift silently beyond our world. Either way, you've come to the right place. Tonight, we're not rushing anywhere. We're not trying to solve anything. We're simply going to float together through the most soothing discoveries about worlds beyond our own. You don't need to remember everything you hear. You don't need to take notes or stay alert. All you need to do is let your breathing slow, your shoulders drop, and allow these quiet wonders to wash over you like gentle waves on a distant shore. Because tonight we're exploring exoplanets, worlds so far away that their light takes years, decades, sometimes centuries to reach us. Worlds where the sunsets paint the sky in colors we've never seen, where the rain might fall upward, and where time itself moves differently than it does here on Earth. Some of what you'll hear might spark a moment of curiosity. Other facts will simply drift by like clouds, soft and weightless. And if these peaceful explorations help you unwind or give you a quiet way to end your day, consider subscribing to join us for more gentle journeys through the universe. It helps others find their way here too, one sleepy soul at a time. Now get comfortable. Let the world outside fade away. And let's begin this slow, wandering voyage to worlds beyond imagination. There's a planet where it rains glass sideways. Deep in the constellation Vulpecula, about 63 light-years from Earth, orbits a world called HD 189733b. It's a beautiful blue marble when seen from space, not unlike our own Earth from a distance. But this blue comes from something far more extraordinary than oceans. The atmosphere of this distant world is filled with tiny particles of silicate, the same material that makes glass. When the winds pick up, which they do constantly at speeds of over 4,000 miles per hour, these glass particles get caught in the atmospheric currents. They swirl and dance through the alien sky, creating sideways storms of crystalline rain that would sparkle like diamonds if you could see them in the starlight. The winds are so powerful on this world that they circle the entire planet in just 30 hours. Imagine standing on the night side of this planet if you could somehow survive there and watching streams of glass particles flowing like luminous rivers through the darkness above. The beauty would be breathtaking, even as it would be utterly lethal to any Earth-based life. It's a reminder that the universe creates beauty in ways we never could have imagined, even in the most extreme and inhospitable places. Some worlds are tidally locked, with one side in eternal day and the other in eternal night. Picture a planet where half the world never sees darkness and the other half never knows light. These tidally locked worlds are more common than you might think. They orbit so close to their stars that gravity has synchronized their rotation with their orbit, much like how our moon always shows us the same face. On the day side of these worlds, temperatures can soar to over 2,000 degrees Fahrenheit. The rocks themselves might glow red hot, and any atmosphere would be stripped away by the intense stellar radiation. But on the night side, it's a completely different story. Here, temperatures plummet to hundreds of degrees below zero. Any atmosphere that manages to exist would freeze solid and fall as snow. The boundary between these two extremes is called the terminator line, and it's one of the most fascinating places in the universe. This twilight zone experiences eternal sunset or sunrise depending on how you look at it. The temperatures here are more moderate, and if liquid water could exist anywhere on such a world, it would be in this narrow band of permanent twilight. Scientists think some of these terminator zones might even have weather patterns unlike anything on Earth. Imagine winds that flow from the scorching day side toward the frozen night side, carrying heat and creating temperature gradients that could support complex atmospheric dynamics. These boundary regions might be oases of relative calm in otherwise extreme worlds. There are planets made almost entirely of diamond. In the depths of space about 40 light-years away in the constellation Cancer, astronomers have discovered something that sounds like it came from a fairy tale. A planet called 55 Cancri A, which appears to be made largely of carbon in the form of diamond. This world is about twice the size of Earth but 8 times more massive, suggesting it's incredibly dense. The surface temperatures reach over 3,000 degrees Fahrenheit, hot enough to melt most metals, but here's what makes it truly extraordinary. The intense pressure and heat on this world have compressed carbon into its most precious form. The entire planet might be a giant gemstone floating in space. If you could somehow mine this world, it would contain more diamond than exists in all the jewelry stores on Earth combined. Of course, the extreme conditions make this impossible, but it's beautiful to imagine a world where the mountains are made of crystal and the valleys sparkle with reflected starlight. The value of such a world would be beyond calculation. Some estimates suggest that if we could harvest even a small portion of this diamond planet, it would be worth more than the entire global economy. But perhaps the real value lies not in what we could take from such a world, but in the simple wonder of knowing it exists out there. A cosmic treasure chest spinning silently through the void. Some exoplanets have multiple suns in their skies. Here on Earth, we're used to our single steady sun rising in the east and setting in the west. But imagine waking up on a world where 2 or even 3 suns hang in the alien sky. These circumbinary planets, as scientists call them, orbit around systems where multiple stars dance around each other in gravitational harmony. The most famous of these is Kepler 16b, often called the real-life Tatooine, after the fictional world from Star Wars. On such a world, the concept of day and night becomes beautifully complex. You might have a sunrise followed by another sunrise as the second star appears over the horizon. Sunsets could involve watching one sun disappear while another continues to light the sky. The interplay of shadows would create patterns unlike anything we see on Earth, with objects casting multiple shadows in different directions as the suns move across the heavens. The seasons on these worlds would be incredibly intricate. Instead of the simple cycle we experience due to Earth's tilted axis, these planets experience seasonal changes based on their orbit around the binary star system. Sometimes they're closer to both stars, sometimes farther away, and sometimes positioned so that one star is blocked by the other. The result would be a complex symphony of warmth and cold, light and shadow, playing out over periods that could last months or years. There are worlds where water behaves in impossible ways. On a planet called GJ 1214b, about 40 light-years from Earth, water exists in a state that doesn't occur naturally anywhere in our solar system. The immense pressure and temperature on this world creates what scientists call hot ice, or superionic water. In this strange state, water molecules break apart, with oxygen atoms forming a crystalline structure, while hydrogen atoms flow through it like a liquid. This isn't the ice we know from our freezers, nor is it the water we drink. It's something entirely different, a hybrid state of matter that exists only under the most extreme conditions. If you could somehow observe this hot ice, it might appear solid, but conduct electricity like a metal. It represents water's ability to transform into something completely unexpected when subjected to alien conditions. Even more intriguingly, some worlds might have oceans of water that never freeze despite being in the cold depths of space. These subsurface oceans are kept liquid by the gravitational heating from their host planets, or by the decay of radioactive elements deep within their cores. The water in these hidden oceans might remain liquid for billions of years, creating stable environments where life could potentially evolve in complete darkness, warmed by the gentle heat from below. Some planets are so light they would float in a cosmic ocean. Saturn is famous for being less dense than water, meaning it would float if you could find a bathtub big enough. But some exoplanets take this to even greater extremes. These superpuff planets, as astronomers playfully call them, are enormous in size but incredibly low in density. They're like cosmic cotton balls, so light and airy that they challenge our understanding of how planets can form and maintain their structure. One such world, WASP 17b, is nearly twice the size of Jupiter, but only about half as massive. If you could somehow compress all of its material, it would fit into a space much smaller than Jupiter. These planets likely have atmospheres that extend far into space. Creating fuzzy, indistinct boundaries on such worlds would be surprisingly void around it. The gravity weak, meaning between the planet, and that if you could somehow visit one. The existence of these super-puff planets suggests that planet formation is far more diverse and creative than we ever imagined. They remind us that the universe doesn't follow the rules we're familiar with from our own solar system. Instead, it explores every possible combination of mass, size, and density, creating worlds that exist at the very edge of what we consider possible. There are planets with skies that shimmer like auroras. On Earth, we're treated to the occasional display of aurora borealis or aurora australis, those dancing curtains of green and blue light that appear near our magnetic poles. But imagine a world where the entire sky shimmers constantly with colors that shift and flow like liquid light. Some exoplanets have magnetic fields so strong and atmospheres so dense that they create permanent auroral displays across their entire surface. These alien auroras might not be limited to the green and blue we see on Earth. Depending on the composition of the planet's atmosphere and the intensity of radiation from its star, the sky could glow in deep purples, brilliant oranges, or colors that don't even have names because human eyes have never seen them. The interplay of magnetic fields, stellar radiation, and atmospheric particles creates world feel like it's wrapped in a constant light show that would make the entire ever-changing luminescence. On some of these worlds, the auroral displays might be so bright that they provide significant illumination, turning night into a soft, colorful twilight. The landscape would be bathed in constantly shifting hues, with shadows that dance and change color as the auroral currents flow overhead. It would be like living inside a cosmic kaleidoscope, where the very air above glows with ethereal beauty. Some exoplanets have clouds made of metal. High in the atmosphere of certain hot Jupiter exoplanets, temperatures and pressures create conditions where metals can exist as gases and form clouds just like water vapor does on Earth. These metallic clouds contain iron, magnesium, and even more exotic metals like vanadium and titanium. When conditions are right, these metals condense and fall as metallic rain, creating precipitation unlike anything in our experience. Imagine watching droplets of liquid iron fall from pearl grey clouds, or seeing titanium snow drift down like metallic confetti. The clouds themselves would have an otherworldly appearance, perhaps shimmering with a metallic luster that catches and reflects the light of their alien sun. The interplay between different metals in the atmosphere could create clouds of varying colors and densities, with iron-rich regions appearing dark and heavy, while titanium clouds might seem lighter and more reflective. These metallic weather systems would create their own unique atmospheric dynamics. The weight and thermal properties of metal particles would affect wind patterns and storm formation in ways completely different from Earth's water-based weather. Lightning strikes in such an atmosphere might create spectacular displays as electrical currents flow through the conductive, metallic particles, turning the entire cloud system into a massive, glowing electrical network. And now, as we drift toward the conclusion of this first part of our journey, let your thoughts begin to settle like stardust on a distant world. We've wandered through realms where glass rains sideways and diamonds form the very ground beneath alien skies. We've visited worlds lit by multiple suns and others where the aurora never fades. These distant planets, spinning quietly in the darkness light years away, remind us that the universe is far stranger and more beautiful than our earthbound imaginations could ever conceive. But this is only the beginning of our exploration. There are so many more worlds waiting to be discovered, each with their own gentle mysteries and quiet wonders. In the next part of our journey, we'll visit planets where the very concept of time flows differently. Worlds that sing in frequencies only they can hear, and places where the impossible becomes beautifully routine. For now, let these images of distant worlds wash over you like waves on a cosmic shore. Whether you're drifting towards sleep or simply finding peace in the vastness of space, know that out there, billions of miles away, these extraordinary worlds continue their silent dance around alien suns, patient and eternal, waiting for us to dream of them. There are worlds where time moves like honey through the cosmos. On a planet called PSR J1719-1438b, something extraordinary happens to the very fabric of time itself. This world orbits incredibly close to what was once a massive star, now collapsed into an object so dense that a teaspoon of its material would weigh as much as Mount Everest. The gravitational pull is so intense that time actually slows down compared to what we experience here on Earth. If you could somehow stand on the surface of this world, watching a clock from Earth, you would see our seconds tick by like minutes. This isn't science fiction. It's the gentle reality of Einstein's universe, where gravity and time dance together in ways that feel almost magical. On this distant world, a day might last what we would consider weeks, not because the planet rotates slowly, but because time itself is stretched like taffy by the immense gravitational field. The sunrises and sunsets would unfold with dreamlike slowness, shadows creeping across the landscape at a pace so gradual you could watch a flower bloom in fast forward compared to the movement of light and shadow. Imagine the profound peace of such a world where everything happens with cosmic patience. The wind would whisper across the surface in slow motion, and rain, if it existed, would fall like gentle meditation, each droplet taking an eternity to complete its journey from cloud to ground. It's a reminder that time itself is not the constant we imagine it to be, but something fluid and changeable, shaped by the very mass of the worlds we inhabit. Some planets have seasons that last for centuries. While we experience the gentle cycle of spring, summer, fall, and winter in the span of a single year, there are worlds where seasons stretch across human lifetimes and beyond. Take HD 80606b, a planet whose elliptical orbit carries it on a journey that makes Earth's seasonal changes seem like rapid flickering. When this world swings close to its star, temperatures soar to over 2,000 degrees Fahrenheit in a matter of hours. But as it travels outward on its elongated path, it enters a cosmic winter that lasts for what would be decades in our time. The beings that might evolve on such a world would experience seasons as we experience geological ages. Entire generations would live and die knowing only winter, passing down stories of the legendary summer that their great-great-grandparents witnessed. The approach of a new season would be a once-in-a-lifetime event, anticipated and prepared for like we might prepare for a rare eclipse or comet. During the brief, scorching summer, the planet's atmosphere would expand and churn with violent storms as the sudden heat creates massive pressure changes. Ice caps that had existed for decades would melt in hours, creating temporary rivers and lakes that would freeze again as the planet swung back into its long, cold journey through space. These worlds teach us that the rhythms we take for granted are just one possibility among countless others scattered throughout the galaxy. There are planets where the very ground beneath your feet would be transparent. In the outer reaches of our galaxy, astronomers have discovered worlds made primarily of water ice, but not the cloudy, opaque ice we know from our winters. Under certain conditions of pressure and temperature, water ice becomes as clear as the finest crystal. On these frozen worlds, you might be able to look down through hundreds of feet of transparent ground, seeing layers of history preserved like pages in a cosmic book. The surface of such a world would be like walking on a frozen ocean of glass. Deep below, you might glimpse the shadows of ancient impacts, fossilized bubbles of gas, or even the ghostly outlines of geological features that formed billions of years ago. The play of light through this transparent landscape would create an otherworldly beauty, with the planet's interior illuminated by filtered starlight that has traveled through, or quality of light, countless layers of crystal-clear ice. Imagine the ether on such a world. Sunbeams would penetrate deep into the planet's surface, creating cathedral-like chambers of illuminated ice far beneath your feet. The very ground would glow with captured starlight, and walking across the surface would feel like floating above an infinite, luminous void. It's a landscape that exists at the boundary between solid and liquid, between opacity and transparency, creating vistas that would challenge our very understanding of what it means to stand on solid ground. Some worlds experience rainfall that defies every law of physics we thought we knew. On the gas giant WASP-76b, the dayside reaches temperatures so extreme that iron vaporizes into the atmosphere like steam. But here's where it becomes beautifully surreal. As the planet rotates and these iron-laden clouds move toward the cooler night side, the metal condenses back into liquid droplets. The result is rain made of molten iron, falling through an alien sky in drops that would glow cherry red as they plummet toward the surface below. This isn't a gentle spring shower, but a downpour of liquid metal heated to over 3,000 degrees. Each droplet would streak through the atmosphere like a tiny meteor, and if you could somehow observe this spectacle from a safe distance, the entire night sky would be filled with glowing, falling stars of iron. The surface, if it exists beneath the thick atmosphere, would ring like a cosmic anvil as this metallic precipitation strikes the ground. But iron isn't the only metal that rains from alien skies. On other worlds, scientists have detected the possibility of aluminum rain, titanium drizzles, and even precipitation made of exotic compounds that don't exist naturally anywhere on Earth. Each type of metallic rain would create its own unique symphony as it falls, with different metals producing different tones and rhythms as they strike the planetary surface below. There are planets where the magnetic, only the universe can hear. Deep field creates music spaces, not the silent void we often imagine. It's filled with radio waves, electromagnetic pulses, and frequencies that dance through the cosmos like an invisible symphony. Some exoplanets have magnetic fields so powerful and complex that they interact with the solar wind from their stars to create radio emissions that could theoretically be converted into sound. These are worlds that literally sing as they orbit their suns. Each planet's song would be unique, determined by the strength of its magnetic field, the composition of its atmosphere, and its distance from its star. Some might produce deep, bass-like tones that resonate through space for light years. Others might create high, crystalline notes that shimmer like wind chimes in the cosmic breeze. A few might generate complex harmonies as multiple magnetic field rate ATD lines vibweave different frequencies simultaneously. If could somehow tune in to these planetary songs, we might discover that each world has its own musical signature, as unique and identifiable as a human voice. The gas giants might produce rich orchestral arrangements with multiple tones weaving together in complex patterns. Rocky worlds might create simpler melodies, perhaps single notes that rise and fall as the planet rotates and its magnetic field orientation changes relative to its star. Some worlds exist in perfect gravitational balance, dancing eternally with their companions. In the vast choreography of space, there are planetary systems where multiple worlds have found perfect harmony, locked in gravitational relationships so precise they seem almost intentionally designed. These are the Trojan planets, worlds that share the same orbital path as a larger planet, but stay positioned at stable points where the gravitational forces of the star and the larger planet create pockets of perfect balance. Imagine two worlds, similar in size, sharing the same orbit around their sun, but always remaining exactly 60 degrees apart, like cosmic dancers who never quite meet but never drift apart either. They would chase each other around their star for billions of years, maintaining their precise separation through the delicate balance of gravitational forces. From the surface of one world, its companion would hang in the sky as a constant, bright star that never moves, never wavers, a celestial lighthouse that has shone in the same spot for eons. These gravitationally balanced worlds represent some of the most stable configurations in the universe. They've found a cosmic sweet spot where all the forces acting upon them are in perfect equilibrium. Seasons on such worlds would be incredibly regular and predictable, with no gravitational perturbations to disturb their gentle, eternal dance. They remind us that even in the apparent chaos of space, there are islands of perfect order and harmony. There are planets where you could walk on water without getting wet. On worlds with extremely low gravity and dense atmospheres, the boundary between liquid and gas becomes beautifully blurred. Some theoretical exoplanets might have atmospheric pressure so high that liquid water at the surface becomes nearly as dense as the air above it. In such conditions, the surface tension of water would be strong enough to support objects that would normally sink, and the dense atmosphere would provide so much buoyancy that walking on water would be as natural as walking on land. These worlds would exist in a state of perpetual mist, where water vapor, liquid droplets, and solid surfaces merge into a seamless continuum. You might step from solid ground onto what appears to be liquid, only to find that the surface supports your weight like a flexible membrane. The landscape would shimmer with moisture that never quite condenses into distinct droplets, creating an environment where the boundaries between different states of matter become meaningless. The very air on such worlds would feel thick and supportive, almost like swimming through an invisible ocean. Movement would be slow and dreamlike, with every gesture cushioned by the dense atmosphere. Sound would travel differently too, creating acoustic properties unlike anything on Earth, where voices might carry for miles through the thick, humid air. And even whispers could echo across vast distances. Some exoplanets are so old they remember the universe's childhood. Among the most ancient worlds discovered is PSR B162026b, a planet that formed when the universe was less than 1 billion years old. This world has been orbiting its binary star system for over 12 billion years, making it older than our entire solar system by more than twice. It's a cosmic elder, a planet that has witnessed the formation and destruction of countless other worlds, the birth and death of generations of stars, and the slow evolution of the galaxy itself. This ancient world carries within its rocks and atmosphere the chemical fingerprints of the early universe, when heavy elements were rare and the cosmic environment was vastly different from what we know today. Its surface might be composed of materials that no longer form naturally in the modern universe, making it a geological time capsule that preserves the conditions of cosmic youth. To stand on such a world would be to touch something that has remained essentially unchanged since the universe's childhood. The mountains and valleys you might see were carved by processes that occurred when the Milky Way was still a chaotic collection of gas clouds beginning to coalesce into the spiral structure we know today. Every rock, every grain of dust would be a relic from an age when the cosmos was young and wild and full of possibilities that no longer exist. As we drift deeper into this cosmic meditation, let your mind wander like starlight across these distant realms. Each world we've visited exists right now, somewhere in the vast darkness beyond our sight, spinning quietly through space with their own unique stories of time and rain and song. They remind us that the universe is not just larger than we imagine, but stranger and more wonderful than we could ever dream. These distant worlds continue their eternal dance, patient and unchanging, waiting in the darkness for the day when we might visit them not just in our dreams, but perhaps in reality. Until then, they remain beacons of possibility, each one a reminder that the universe is full of gentle mysteries waiting to be discovered. There are worlds where gravity is so gentle you could leap between mountains. Imagine stepping onto the surface of Kepler 438b, a world only slightly larger than Earth, but with gravity so weak that your body would feel lighter than a feather. Here, a casual jump might carry you hundreds of feet into the air, and you could bound across landscapes with the effortless grace of a cosmic dancer. The horizon would curve away beneath you as you soar through gentle arcs, each landing soft and dreamlike on this world where the very ground seems to release its hold on everything that touches it. The physics of movement on such a world would transform the simplest actions into poetry. Walking would become a series of floating steps, each stride carrying you forward in long, graceful bounds. The dust kicked up by your feet would hang in the thin air for minutes before settling back to the surface like cosmic snow. Even the way plants might grow would be different, with flowers reaching impossible heights on stems so delicate they would crumble under Earth's heavier grip. The gentleness of such gravity would create landscapes unlike anything in our experience. Rock formations could grow tall and thin, reaching toward alien skies without the weight that would topple them on our world. Waterfalls, if they existed, would cascade in slow motion, each droplet following lazy parabolic paths through the air. It would be a world where the very laws of physics seem softened, where everything moves with the unhurried grace of a dream. Some planets orbit their stars backwards, spinning against the cosmic current. While most worlds follow the same direction of rotation as their host star, there are rebellious planets that have somehow been knocked into retrograde orbits, spinning backwards through space like cosmic salmon swimming upstream. WASP-17b is one such world, a gas giant that travels around its star in the opposite direction from which the star itself rotates. Scientists believe these backwards worlds were likely knocked off their original course by gravitational encounters with other planets or passing stars. Their orbits gradually shifted over millions of years until they found themselves moving against the flow of their stellar system. The result is a world that experiences its seasons and day-night cycles in reverse patterns compared to its neighbors, creating unique atmospheric dynamics as the planet's rotation works against the natural flow of stellar radiation. On such a world, the weather patterns would be extraordinary. Winds that might normally flow in predictable directions would be disrupted by the planet's backward spin, creating atmospheric chaos that could generate storms unlike anything in our solar system. The very auroras in its sky would dance differently, following magnetic field lines that have been twisted and distorted by the planet's contrary motion through space. There are worlds covered in oceans deeper than the distance from Earth to space. In the outer reaches of stellar systems where starlight barely reaches, exist worlds like GJ1214b that harbor oceans so deep they dwarf anything in our imagination. These water worlds might have seas that extend down for hundreds of miles, far deeper than the distance from the surface of our planet to the edge of space. At these crushing depths, water takes on properties that seem almost magical, compressed into forms that don't exist anywhere in our solar system. The pressure at the bottom of these cosmic oceans would be so intense that water molecules themselves begin to behave differently, forming crystalline structures that are simultaneously liquid and solid. These deep sea floors would be landscapes of wonder, where mountains of compressed water ice rise through liquid depths that have never known sunlight. Strange currents would flow through these abyssal plains, carrying heat from radioactive decay in the planet's core, creating thermal vents that might support forms of life we've never imagined. The journey from the surface to the bottom of such an ocean would be like traveling through different worlds entirely. The upper layers might be familiar liquid water, but as you descended, you would pass through zones where the water becomes increasingly exotic, until finally reaching depths where the very concept of liquid and solid loses meaning in the face of pressures that could compress diamond. Some exoplanets have atmospheres made of precious gems in gaseous form. High above the cloud tops of certain ultra-hot Jupiters, temperatures soar to levels where even the most precious materials on Earth exist as vapors. On planets like HAT P7b, rubies and sapphires don't form in the ground, but float as gases in the upper atmosphere, creating clouds of vaporized gemstones that drift across alien skies like crystalline dreams. These gem-laden atmospheres would create optical effects beyond imagination. Through clouds, sunlight passing of gaseous corundum would scatter in ways that paint the sky in colors that have no names. The very air would shimmer with the essence of precious stones. An atmospheric phenomena like lightning would illuminate these gem gas clouds from within, creating displays of light and color that would make Earth's most spectacular sunsets pale in comparison. When conditions are right, these gaseous gems might condense into tiny, crystalline particles that fall like glittering snow. Imagine standing beneath a sky where microscopic rubies drift down like cosmic confetti, each particle catching and reflecting the light of an alien sun. The landscape would be dusted with a treasure that on Earth would be worth fortunes, but on these distant worlds exists as naturally as morning dew. There are worlds where the very concept of surface dissolves into ambiguity. Some gas giants possess such gradual transitions between their atmospheres and any solid core they might have that the idea of standing on solid ground becomes meaningless. These worlds exist as continuous gradients of density, where what begins as thin, wispy clouds gradually becomes thicker and thicker until somewhere deep below, it might transition into liquid or solid without any clear boundary to mark the change. On such worlds, the question, where does the atmosphere end and the surface begin, has no answer. You could descend through layers of increasing density for hundreds or thousands of miles, each level feeling slightly more substantial than the last, but never encountering anything you could definitively call ground. It would be like sinking slowly through cosmic honey, where every mile downward brings slightly more resistance, but never the solid reassurance of something to stand upon. These gradient worlds challenge our Earth-based concepts of what it means to be on a planet. There would be no beaches where ocean meets land, no mountain tops where rock meets sky. Instead, everything would exist in a state of beautiful uncertainty, where the boundary between flying and walking, between swimming and standing, becomes a matter of depth rather than a fundamental change in the nature of the world around you. Some planets experience eclipses that last for years. In binary star systems where planets orbit both stars, the dance of celestial bodies creates eclipse patterns of extraordinary complexity and duration. A world might pass behind one of its suns for months at a time, experiencing an extended twilight that gradually deepens into darkness before slowly brightening again as the planet emerges from the stellar shadow. During these extended eclipses, the planet would be illuminated only by its second sun, creating lighting conditions that shift gradually over the course of the eclipse. The landscape would take on strange, unfamiliar colors as the spectrum of light changes, and shadows would behave in ways that defy Earth-based intuition. Plants and weather patterns would adapt to these long cycles of varying illumination, creating ecosystems that pulse with rhythms measured in seasons rather than days. The beauty of such extended eclipses would be in their subtlety. Unlike the dramatic few minutes of a solar eclipse on Earth, these cosmic events would unfold with the patience of geological time. The sky would gradually shift through spectrums of color as one sun disappears and the other becomes the sole source of light, painting the world in hues that change so slowly you might not notice them from day to day. but which transform the entire character of the world over the course of the eclipse. There are worlds where volcanoes erupt liquid diamond instead of lava. On carbon-rich planets with extreme internal pressures, volcanic activity takes on forms that would seem like fantasy on Earth. Instead of molten rock, these volcanoes might erupt liquid carbon under such intense heat and pressure that it flows as streams of molten diamond across alien landscapes. The result would be terrain sculpted not by basalt and granite, but by the hardest material known to science. These diamond volcanoes would create landscapes of impossible beauty. Hardened flows, valleys, and mountains of crystallized carbon would form that catch and refract light in ways that turn entire continents into natural prisms. When the alien sun rises over such terrain, the landscape itself would become a source of light, splitting solar radiation into rainbow spectrums that dance across surfaces too hard for any earthly tool to scratch. The very concept of erosion would be different on such worlds. Where Earth's mountains slowly wear away under the patient action of wind and water, diamond peaks would stand unchanging for billions of years, their crystalline facets as sharp and clear as the day they cooled from their molten state. Rivers, if they could exist, would be forced to find paths around obstacles that refuse to yield, creating drainage patterns of perfect geometric precision. Some exoplanets have magnetic fields so powerful they could strip paint from spacecraft. The magnetic environment around certain worlds creates fields of force that dwarf anything we experience on Earth. Jupiter's magnetic field is already strong enough to damage unshielded electronics, but some exoplanets possess magnetospheres so intense they could literally tear apart metallic objects through magnetic stress alone. These magnetic giants would create auroral displays of unimaginable intensity, with charged particles from their host stars being accelerated to such high energies that the entire planet would be wrapped in a constantly shifting cocoon of electromagnetic radiation. The magnetic field lines would be visible as streams of glowing plasma that arch from pole to pole, creating a cage of light around the world that pulses and flows with the rhythm of stellar weather. A moon orbiting such a world would be subjected to magnetic forces that could reshape its very structure over geological time. Metallic ores would be pulled and stretched by the powerful fields, creating geological formations that align with magnetic rather than gravitational forces. The very rocks would remember the magnetic environment that formed them, frozen into patterns that map the invisible forces that shaped their world. And so we drift onward through this gentle catalogue of cosmic wonders, each world more extraordinary than the last. These distant planets continue their silent orbits in the darkness, carrying with them secrets of physics and chemistry and beauty that we're only beginning to understand. They remind us that the universe is not just vast in scale, but infinite in its capacity for surprise and wonder. In the time it has taken you to hear about these worlds, light from some of them has traveled a little closer to Earth, carrying information about their alien skies and impossible landscapes. That light will arrive long after we're gone, but it will arrive nonetheless patient and persistent, bringing news from realms where gravity whispers instead of pulls, where rain falls upward, and where time itself moves like honey through the cosmic dark. There are worlds where sound travels through solid ground instead of air, on planets with atmospheres so thin they barely exist, yet with rocky surfaces that ring like cosmic bells. Vibrations move through the planet's crust in ways that would feel magical to our Earth-trained senses. These worlds have learned to speak through stone, where footsteps create ripples that travel for miles beneath the surface, and where the planet itself becomes a vast musical instrument played by the wind, by falling rocks, by the subtle shifts of thermal expansion as alien suns rise and set. The inhabitants of such a world, if they exist apping messages, might communicate by teed into the ground, sending coded rhythms that race through the planetary crust, faster than any voice could carry through the whisper-thin atmosphere above. Mountain ranges would act as amplifiers, focusing and directing these underground songs across continents. The very geology would become a network of communication, with different types of rock creating different tones and overtones as vibrations pass through them. Imagine placing your ear to the ground on such a world and hearing the symphony of an entire planet. The slow, deep bass notes of continental drift, the sharp percussion of meteor impacts, the gentle melody of wind-carved stone singing in frequencies too low for human ears to detect, but felt as vibrations that travel through bone and tissue like the memory of sound. Some planets are perfectly smooth, with no mountains or valleys anywhere. In the outer reaches of certain star systems orbit worlds that have been shaped by forces so gentle and persistent that every irregularity has been worn away over billions of years. These sphere planets exist in a state of perfect equilibrium, where gravity has smoothed away every mountain, filled every valley, and created surfaces as flawless as polished marble stretching from horizon to horizon. Walking across such a world would be like traversing an infinite ball bearing, where the curvature of the planet is the only variation in an otherwise perfectly uniform landscape. The horizon would always be exactly the same distance away, no matter which direction you faced, and the gentle curve of the surface would create optical illusions where distant objects seem to float above the perfect sphere of the ground. These worlds might be covered in shallow, perfectly uniform oceans that follow the planet's spherical surface without interruption. No continents would break the endless expanse of water. No islands would provide reference points for navigation. It would be a world of pure geometry, where the only landmarks are the patterns of light and shadow created by the movement of alien suns across mathematically perfect skies. There are worlds where crystals grow so large they form entire continents. On planets rich in silicon and other crystal-forming elements, geological processes over billions of years have created structures that dwarf any earthly gemstone. These crystal worlds might have continents made from single, massive quartz formations that stretch for thousands of miles, their faceted surfaces creating landscapes that bend and focus starlight into concentrated beams that sweep across the planet like cosmic searchlights. The valleys between these crystal continents would be lined with smaller gems, each one perfectly formed and clear as the finest glass. Walking through such terrain would be like moving through a cathedral made of light itself, where every surface reflects and refracts the illumination from above, creating an environment where the very ground beneath your feet glows with captured radiance. Weather on crystal worlds would behave in extraordinary ways. Rain falling on perfectly smooth crystal surfaces would create rivers of pure water that flow without friction, accelerating to incredible speeds as they follow the geometric channels carved by millions of years of similar storms. The sound of water on crystal would ring like music across these gemstone landscapes, creating natural orchestras that play with every shower. Some exoplanets have gravity that changes depending on where you stand. On worlds with unusual internal structures or complex gravitational interactions with multiple moons, the strength of gravity itself becomes a variable that changes as you move across the planet's surface. There might be regions where you feel lighter than air, able to leap enormous distances with minimal effort, while other areas press down upon you with weight that makes every step a struggle. These gravitational anomalies would create landscapes where water flows uphill in some places and struggles to fall in others. Plants might grow in impossible spirals, following the invisible contours of gravitational fields rather than reaching straight toward the sun. The very architecture of erosion would be shaped by these changing forces, creating geological formations that twist and bend in ways that reflect the hidden patterns of mass and energy buried deep within the planet's core. Travelers on such worlds would need to navigate not just by compass and map, but by the feel of their own weight, learning to read the subtle changes in gravity that indicate their position relative to the planet's internal structure. Some areas might be gravitational oases where movement is easy and effortless, while others would be zones of crushing weight where survival depends on careful preparation and respect for the invisible forces at work. There are worlds where the air itself glows with gentle phosphorescence. In the upper atmospheres of certain gas giants, chemical reactions triggered by stellar radiation create a subtle luminescence that makes the very air shine with soft, otherworldly light. These worlds exist in a permanent state of gentle twilight, where the atmosphere itself becomes a source of illumination that never quite fades to complete darkness. The glow might shift in color and intensity based on atmospheric conditions, creating weather patterns visible as changes in the ambient light itself. Storm systems would appear as darker regions where the phosphorescent chemicals are diluted or disrupted, while clear skies would shine more brightly. The interaction between this atmospheric glow and any solid surfaces below would create lighting conditions unlike anything we know, where shadows are soft and diffuse, and the boundary between day and night becomes a matter of subtle gradations rather than distinct transitions. Flying creatures on such worlds would navigate by the patterns of atmospheric luminescence, reading the sky like a vast, ever-changing map written in living light. The very act of breathing would involve drawing in air that carries its own gentle radiance, making every exhalation a small puff of glowing mist that fades slowly into the phosphorescent background. Some planets are so close to their stars that their surfaces are molten seas of liquid rock. On worlds like Corot 7b, the day side faces such intense stellar radiation that solid rock melts into glowing oceans of lava that stretch from horizon to horizon. These molten worlds exist in a state of constant geological flux, where the very concept of solid ground becomes meaningless under temperatures that exceed 2000 degrees Celsius. The beauty of these lava worlds lies in their constant motion. Currents of molten stone flow across the surface in patterns that shift and change like liquid fire. Waves of melted rock might rise and fall in slow motion, creating geological tides driven by the gravitational pull of nearby moons or the asymmetric heating from their close orbiting stars. The night sides of such worlds, if they exist, would be landscapes of cooling rock that never quite solidify before the planet's rotation brings them back into the stellar furnace. This eternal cycle of melting and cooling would create surface features that exist in constant transition, never permanent, always flowing between liquid and solid states like a planet-sized lava lamp spinning slowly through space. There are worlds where the seasons are measured not in months, but in millennia. On planets with orbital periods that span thousands of Earth years, the concept of seasonal change takes on an almost geological significance. A single winter might last longer than all of recorded human history, while the coming of spring becomes a mythical event that civilizations might wait centuries to witness. The gradual transition between these extended seasons would be so slow as to be almost imperceptible within a human lifetime. Generations would live and die knowing only the slow progression from deep winter towards spring, passing down stories and preparations for seasonal changes that their great-grandchildren might finally witness. Ice caps that form during the long winters would be kilometers thick, and their melting during the brief summers would reshape entire continents. These worlds would develop ecosystems adapted to think in geological time, with life cycles that span not years, but centuries. Plants might remain dormant for decades, waiting for the right combination of temperature and light that signals the arrival of their brief growing season.
Animals might hibernate for generations,
their metabolism slowed to a crawl that allows them to survive the endless seasons of their slowly orbiting world. Some exoplanets have auroras that paint the entire sky in colors that have no names. While Earth's auroras are limited to polar regions and occasional displays during strong solar storms, certain worlds possess magnetic fields and atmospheric conditions that create auroral displays across their entire sky, turning the heavens into a constantly shifting canvas of impossible colors. These planet-wide auroras might include hues that exist only under alien atmospheric conditions.
Frequencies of light that Earth's atmosphere filters out before they can reach our eyes. The interaction between exotic
Atmospheric gases and high-energy particles from their host stars creates combinations of colors that would challenge human perception. Imagine skies that shift through spectrums of ultraviolet purple, infrared red, and colors that exist in the spaces between what we consider distinct hues. The entire dome of the sky would pulse and flow like a living thing, with patterns that spiral and dance from horizon to horizon. These perpetual light shows would affect every aspect of life on such worlds. The constant auroral illumination would mean that true darkness never falls, creating ecosystems that exist in eternal twilight painted with the shifting colors of the magnetic sky above. Navigation would be by the patterns of the aurora rather than by stars, and the very culture of any
inhabitants would be shaped by the knowledge
that their sky is alive with light that dances to rhythms older than their civilization. There are worlds where gravity is so weak that atmospheres extend into space like cosmic hair. On planets with minimal mass but significant rotation, the boundary between atmosphere and space becomes beautifully blurred. These worlds spin so rapidly and possess so little gravitational pull that their atmospheres stretch outward into long, gossamer streams that trail behind the planet like the tail of a comet made of air itself. These atmospheric tails would be visible from space as delicate wisps of gas that flow away from the planet in directions determined by stellar winds and the planet's own motion through its orbit. The upper reaches of such atmospheres would be so thin and extended that spacecraft could pass through them without resistance, flying through clouds of gas that technically belong to the planet but exist in the vacuum of
space. Living on the surface of such a world would involve breathing air so light
that it barely registers as atmosphere at all. The sky would fade gradually into space without any clear boundary, and looking up would reveal stars shining through layers of increasingly thin gas that shimmer and dance like heat mirrors on a summer day. Weather systems would be gentle and extended, with storm clouds that might reach from the surface all the way to the edge of space. Some planets are locked in eternal dance with their moons, spinning at exactly the same rate as their satellites orbit. These tidally locked systems create worlds where one face always looks upon their moon while the other never sees it, dividing the planet into the moonlit hemisphere and the moonless hemisphere. The psychological and cultural implications for any inhabitants would be profound, with entire civilizations developing on one side or the other of this cosmic divide. The moonlit side would experience a satellite that never moves in the sky, hanging like a permanent celestial lighthouse that provides constant illumination during the planet's night cycles. This moon would show its phases in perfect regularity, but always from the same position in the heavens, creating a reliable celestial clock that never varies in its location. Tides would be constant and predictable, with high water always occurring in the same geographical locations. Meanwhile, the moonless hemisphere would develop under skies where no large satellite ever appears, creating cultures that might not even know of their moon's existence unless they traveled to the other side of their world. The contrast between these two hemispheres would be as fundamental as the difference between day and night, creating two distinct worlds sharing the same planetary surface. And now,
as we continue our gentle drift through these cosmic possibilities,
let your thoughts flow like the atmospheric tails of those distant, rapidly spinning worlds. Each planet we visited exists somewhere in the vast darkness, spinning through space with its own unique relationship to time, gravity, and light. They are reminders that the universe creates beauty and wonder in forms we're still learning to imagine. Each world a masterpiece of physics and chemistry working together to create something entirely new. These distant realms continue their patient orbits, carrying their secrets of crystal continents and glowing skies,
of gravity that shifts like weather and seasons that span millennia.
They wait in the cosmic dark, these worlds where sound travels through stone and rain falls upward, where the very air shines with its own light and time itself moves differently than we've ever known. There are worlds where music is written in the movement of their rings. Some planets possess ring systems so complex and dynamic that they create symphonies visible from space. Unlike Saturn's relatively stable rings, these worlds have orbital debris that spirals and dances in patterns that shift like sheet music written across the cosmos. Gravitational resonances between the planet and its moons create gaps and waves in the ring material that pulse with mathematical precision, each disturbance traveling around the planet like notes flowing across a cosmic staff. The rings themselves might be composed of materials that catch and reflect light in different ways, creating visual harmonies where ice particles shine silver, rocky debris glows amber, and metallic fragments flash like percussion instruments in the starlight. As the planet rotates, these rings would create ever-changing patterns of light and shadow on the surface below, painting the landscape with moving melodies of brightness and dark. Watching these ring symphonies from the planet's surface would be like observing music made visible, with crescendos marked by the brightening of reflective particles and diminuendos represented by the gentle fading of light as debris moves into shadow. The very rotation of the world would conduct this celestial orchestra, keeping time for a performance that has been playing for millions of years and will continue long after any audience has gone. Some exoplanets exist in a state of perpetual fog, where the boundary between air and water disappears entirely. These mist worlds maintain atmospheric conditions where water vapor exists at the perfect temperature and pressure to remain suspended indefinitely, creating planets wrapped in clouds so thick and persistent that solid surfaces become theoretical concepts rather than experienced realities. The fog on these worlds isn't weather, it's climate, a permanent condition that turns the entire planet into a three-dimensional ocean of suspended droplets. Navigation on such worlds would be entirely by feel and sound, with visibility extending only a few feet in any direction. Every surface would be perpetually damp, and the air itself would feel substantial, almost swimmable. Sounds would travel in strange ways through the dense mist, with voices seeming to come from everywhere and nowhere at once, creating acoustic environments where whispers can carry for miles while shouts might be muffled after just a few yards. The ecology of these fog worlds would be unlike anything on Earth, with plants that have evolved to capture moisture directly from the air rather than through their roots, and creatures that navigate by echolocation or other senses entirely. Light would behave differently too, scattered and diffused by the omnipresent water droplets into a soft, directionless glow that makes every moment feel like perpetual dawn or dusk. There are worlds where your feet is constantly our ground beneath the arranging itself. On planets with unusual magnetic properties, ferrous materials in the surface layers respond to changes in the planet's magnetic field by literally moving and reshaping the landscape. These magnetically active worlds experience geological changes not over millions of years, but over days or hours, as iron-rich sands and metallic rocks flow like slow rivers in response to magnetic currents deep within the planet's core. Walking across such terrain would require constant awareness of the shifting ground, where pathways that existed in the morning might be gone by afternoon. replaced by entirely new configurations of metallic hills and valleys. The landscape would be alive in a very real sense, breathing and moving with the rhythm of magnetic tides that ebb and flow according to patterns written in the planet's electromagnetic field. These worlds would create their own unique forms of erosion and deposition, where magnetic storms could literally reshape continents by pulling metallic materials from one region and depositing them in another. Rivers might change course not because of water flow, but because the magnetic alignment of their beds has shifted, creating new channels while abandoning old ones that no longer follow the planet's electromagnetic contours. Some planets have weather systems that create their own light through friction and electrical discharge. On worlds with atmospheres so dense and active that wind speeds regularly exceed the sound barrier, the sheer friction of air movement generates enough heat and electrical activity to create a planet-wide network of atmospheric lightning. These worlds exist in a constant state of electrical storm, but rather than being chaotic and destructive, the lightning follows predictable patterns based on atmospheric pressure systems and planetary rotation. The result is weather that provides its own illumination, with storm systems that glow from within as they move across the planet's surface. Cloud formations would be outlined in crackling electrical discharges, and the very wind would carry a charge that makes the air itself luminous. These electrical weather patterns would create a form of atmospheric communication, with different types of storms generating different frequencies of electromagnetic radiation. The surface of such worlds would be constantly illuminated by the dancing lights of electrical weather overhead. No artificial lighting would ever be necessary, as the sky itself would provide a continuous display of natural electrical illumination that shifts and changes with the movement of weather systems. The very air would tingle with electrical potential, making every breath a small encounter with the planet's electromagnetic vitality. There are worlds where time zones are measured in geological ages rather than hours. On planets with rotation periods so slow that a single day lasts longer than an Earth year, the concept of time zones takes on almost mythical significance. Different regions of such a world might experience what we would consider entirely different seasons based solely on their position relative to the slowly moving terminator line between day and night civilizations. On these worlds would develop entirely different relationships with time, where the movement of shadows becomes a generational event and the progression from dawn to midday represents the work of lifetimes. Ancient sundials might mark not hours but decades, and the simple act of watching the sun move across the sky would require the patience of geological observation. The weather patterns on such slowly rotating worlds would be unlike anything we know, with massive atmospheric circulation systems that take months to complete a single cycle. Storm systems could maintain their structure for what we would consider years, slowly traversing the planet's surface like mobile weather nations that bring their own climate zones wherever they travel. Some exoplanets have surfaces made of materials so reflective they act like cosmic mirrors. These worlds, covered in crystalline formations or metallic deposits polished smooth by eons of atmospheric action, reflect so much light that they shine like stars in the darkness of space. The surface of such a planet would be blindingly brilliant when illuminated by its host star, creating an environment where shadows are rare and the landscape glows with reflected radiance. Walking on such a world would require protection, not just from direct starlight, but from the intense glare of light bouncing off every surface. The entire planet would act like a massive mirror, focusing and redirecting stellar radiation in ways that create complex patterns of illumination and reflection. Some areas might become focal points where reflected light concentrates into beams hot enough to melt metal, while others remain in relative dimness despite the overall brilliance of the world. These mirror worlds would be visible from enormous distances, their reflected light serving as beacons that could be detected by civilizations many light years away. They represent planets that don't just absorb the energy of their stars, but actively participate in the cosmic distribution of light, sending stellar radiation bouncing back into space in directions that might illuminate other worlds or provide navigation references for travelers crossing the interstellar
void. There are worlds where the very concept of
weather includes phenomena that exist in dimensions we can barely comprehend. On planets where the laws of physics operate under conditions so extreme that space and time themselves become variable, weather systems might include storms of gravitational waves, precipitation of exotic matter that exists only under specific cosmic conditions, and atmospheric pressures that cause the fabric of reality itself to ripple and distort. These cosmic weather systems would affect not just the planet's surface, but the flow of time and the strength of gravity in localized regions. A gravitational storm might cause time to slow down in certain areas while accelerating it in others, creating temporal weather patterns where the very rate of existence becomes subject to meteorological variation. Travelers on such worlds would need to navigate not just through space, but through different rates of temporal flow. The beauty of such phenomena would be visible only to observers who could perceive the warping of space-time itself. Systems create visual dist, watching as gravitational weather oceans that bend light and stretch distances in patterns that shift and flow like atmospheric fronts moving across more familiar skies. These worlds exist at the very edge of what we can conceive, where weather and physics merge into something that challenges our most basic understanding of what it means to exist in physical reality. Some planets are so ancient that they predate the formation of heavy elements in the universe. These primordial worlds formed when the cosmos was young and the only elements available were hydrogen and helium, the simplest building blocks of matter. They represent time capsules from an era when the universe was fundamentally different, before generations of stars had lived and died to create the carbon, oxygen, and metals that we consider essential for complex planetary formation. The surfaces of these ancient worlds would be composed of materials that no longer form naturally in the modern universe, compounds and structures that exist only because they were created under the unique conditions of cosmic youth. Their atmospheres might contain gases that have since been processed and transformed by billions of years of stellar evolution, preserving chemical signatures from the universe's earliest epochs. To study such worlds would be like reading the universe's diary from its childhood, examining rocks and atmospheric compositions that remember a time when galaxies were just beginning to form and the first stars were igniting the darkness of primordial space. Every sample from such a world would be a message from deep time, carrying information about conditions that existed when the cosmos was still learning how to create the complex chemistry that would eventually lead to life. There are worlds where the aurora never fades, painting permanent rivers of light across skies that never know true darkness. These worlds exist in such perfect alignment with their host stars, magnetic fields, and solar wind patterns that auroral displays become as constant and reliable as sunrise and sunset on Earth. The magnetic field lines of these planets channel charged particles into continuous streams of illumination that flow across their skies like luminous
rivers that never run dry. The aurora on these worlds wouldn't be the
occasional treat that we experience on Earth, but a permanent feature of the landscape, as reliable and constant as mountains or oceans. Different regions of the planet would be known for their characteristic auroral colors and patterns, with some areas experiencing gentle green curtains, while others might be bathed in the brilliant purple and red of higher energy displays. Life on such worlds would evolve under skies that are never truly dark, developing in the constant presence of shifting colored light that dances overhead. Navigation would be by auroral landmarks rather than stars, and the very culture of any inhabitants would be shaped by the knowledge that their sky is alive with permanent rivers of light that have flowed overhead since before their civilization began, and So we continue our gentle drift through these realms of wonder, each world more extraordinary than the last. In the time you've spent listening to these cosmic lullabies, countless exoplanets have completed fractions of their orbits. Their magnetic weather systems have shifted, their crystal continents have caught new angles of starlight, and their atmospheric symphonies have played movements that no ear will ever hear, but which continue nonetheless in the patient darkness of space. These worlds remind us that the universe is not just vast in scale, but infinite in its creativity. Every possible combination of mass and energy, every conceivable interaction between matter and force, every imaginable relationship between time and space is being explored somewhere in the cosmic dark, on worlds that spin silently through the void, carrying their impossible secrets with the patience of eternity itself. There are worlds where gravity flows in currents like an invisible ocean, on planets with cores that shift and pulse with tidal forces from multiple stars. Gravitational fields don't remain constant across the surface. Instead, they ebb and flow in predictable patterns, creating regions where objects might drift gently upward during certain times of day, then settle back down as the gravitational tide changes. These worlds exist in a state of perpetual weightlessness variation, where the very force that holds things to the ground becomes as changeable as weather. But walking across such terrain would feel like swimming through an invisible medium that sometimes supports you and sometimes releases you to float freely above the surface. Trees might grow in spiraling patterns, their branches following the flow of gravitational currents rather than reaching directly skyward. Rivers would meander not just according to the lay of the land, but following paths of least gravitational resistance, creating waterways that seem to defy logic as they flow uphill in some places and accelerate dramatically in others. The tides on these worlds wouldn't just affect oceans, but everything on the surface. Dust would drift in lazy spirals during low gravity periods, while high gravity zones would pull debris from the atmosphere like cosmic vacuum cleaners. The very architecture of erosion would be shaped by these gravitational flows, creating landscapes that seem to have been carved by invisible hands, following patterns only they could understand. Some exoplanets experience seasons based on the color of light their star produces. Unlike Earth, where seasons are caused by axial tilt, certain worlds orbit variable stars that change their spectral output in predictable cycles. During blue light seasons, when the star emits primarily in the blue spectrum, photosynthesis and atmospheric chemistry operate differently than during red light seasons, when the stellar output shifts toward longer wavelengths. These chromatic seasons would create ecosystems that pulse with color-based rhythms completely unknown on our world. Plants on such worlds might have evolved to absorb different wavelengths during different seasons, changing their own colors to match the shifting spectrum of their sun. During blue seasons, foliage might appear silver or white to reflect the harsh blue radiation, while red seasons could bring out deep purples and magentas as plants adapt to harvest the gentler, longer wavelengths. The very sky would shift through a spectrum of colors as the stellar output changes, creating atmospheric conditions that paint the world in hues that follow astronomical rather than meteorological patterns. Animal life would synchronize their reproduction and migration patterns not with temperature changes, but with the shifting colors of sunlight. Creatures might hibernate during certain spectral periods when their food sources can't photosynthesize effectively, emerging only when the star's output returns to wavelengths that support their ecosystem's primary producers. It would be a world where color itself becomes a fundamental environmental variable. There are worlds where the magnetic field creates permanent sculptures in the atmosphere. On planets with incredibly strong and precisely aligned magnetic fields, charged particles from stellar wind don't just create aurora, they become trapped in stable configurations that persist for centuries. These magnetic sculptures hang in the upper atmosphere like cosmic art installations,
visible from the surface as permanent fixtures in the sky that neither
fade nor move, but remain frozen in patterns dictated by the planet's electromagnetic geometry. These atmospheric sculptures would serve as reliable navigation landmarks, unchanging reference points that civilizations could use for mapping and orientation across generations. Each sculpture would have its own characteristic shape and color determined by the specific magnetic field configuration that traps and energizes the charged particles. Some might appear as spiraling helixes of green light, while others could form geometric patterns of blue and purple that stretch across hundreds of miles of sky. The beauty of these permanent displays would be in their constancy. Unlike Earth's variable aurora that comes and goes with solar activity, these magnetic sculptures would be as reliable as constellations but far more dramatic, creating skylines where the heavens themselves are decorated with persistent works of electromagnetic art that have been slowly rotating with the planet's magnetic field for millennia. Some eternal planets have atmospheres so thick that sound travels faster than light can penetrate. In the crushing depths of super-dense atmospheric layers, sound waves move with such speed and efficiency that acoustic communication becomes more reliable than visual signals. These worlds exist in a state of perpetual acoustic twilight, where the dense atmosphere filters and scatters light so effectively that even the brightest stars appear as dim suggestions, while sounds carry with crystalline clarity across vast distances. On such worlds, creatures would navigate and communicate primarily through sound, developing acoustic abilities that would seem supernatural by Earth standards. Echolocation would be refined to an art form, with organisms capable of building detailed three-dimensional maps of their environment using sound alone. The very landscape would become an acoustic instrument, with different geological formations creating distinct sound. Signatures that could be read like a topographical map made of audio. Weather systems on these acoustically dominant worlds would be defined as much by their sound as their appearance. Storm fronts would be preceded by characteristic acoustic signatures, and the movement of wind through the dense atmosphere would create musical tones that shift and change based on atmospheric pressure and density. The planet itself would sing with the voice of its weather, creating a global symphony that never stops playing. There are worlds where mathematics becomes visible in the structure of their crystal formations. On planets where silicon-based chemistry dominates and geological processes operate under precise temperature and pressure conditions, crystal growth follows mathematical patterns so perfect that the entire surface becomes a 3. These crystalline worlds display dimensional textbook of geometry, Fibonacci spirals in their mineral formations, fractal patterns that repeat at every scale, and geometric relationships that make the underlying mathematical nature of physical law visible to the naked eye. Walking across such terrain would be like moving through a living mathematical proof, where every rock formation demonstrates principles of symmetry, proportion, and geometric growth. The crystals themselves would be organized according to mathematical constants, with formations that display the golden ratio, prime number sequences, and other fundamental mathematical relationships worked out in mineral structures that have been growing according to these principles for millions of years. These mathematical landscapes would be tools for understanding the universe's deepest patterns. Every crystal cluster would be a natural computer, processing the mathematical relationships inherent in the physical laws that govern crystal growth. The planet would be covered with mineral libraries that record the mathematical constants and relationships that define reality itself, written in silicon and trace elements over geological time scales. Some exoplanets exist in perfect synchronization with cosmic rhythms we're only beginning to understand. These worlds orbit not just their stars, but dance to gravitational beats that involve multiple stellar systems, galactic rotation patterns, and even larger cosmic structures. Their days, seasons, and years align with astronomical cycles that span millions of years, creating worlds where time itself is measured against the universe's largest clockwork mechanisms. The inhabitants of such precisely synchronized worlds would experience time as a multi-layered phenomenon, where daily rhythms nest within seasonal cycles that nest within cosmic epochs in perfect mathematical harmony. Their civilization would develop with an inherent understanding of their place in the universe's largest patterns, creating cultures that think naturally in terms of galactic time and cosmic seasons. These worlds represent the ultimate expression of celestial mechanics, where every gravitational influence from the smallest moon to the largest galactic structure contributes to a single, perfectly coordinated dance that has been performing for billions of years. They are cosmic timepieces, keeping track of rhythms so vast that entire civilizations rise and fall within single beats of their astronomical percussion. And now, as our gentle journey through these cosmic wonders draws to its close, let the images of these distant worlds settle softly in your mind like stardust on a quiet shore. We've drifted together through realms where time flows like honey, where rain falls upward made of liquid metal, and where entire planets sing songs only the universe can hear. Each of these extraordinary worlds continues spinning silently in the darkness, carrying their impossible secrets with the patience of eternity itself, waiting in the cosmic night for us to dream of them once more.